We will pass to our last presenter, Engineer Konouz Zaki. Konouz Zaki will present us about membrane-based dairy wastewater treatment and lactose recovery. Engineer Konouz graduated from the Faculty of Engineering at Alexandria University. She is working as teacher assistant.
Morning. Good afternoon. First of all, I want to thank Dr. Hassan Harab and Dr. Manu Shalabi for me presenting here. I will talk about membranes in dairy industry and lactose recovery. First of all, dairy industry is one of our important industries worldwide, even because of different products we already use, like yogurt, cheese, milk, and milk powder, soap, and the water consumption varies between 1.5 to 5 liters per liter for the manufacturing of 1 liter of milk. So this industry is important for our worldwide. Accordingly, the wastewater from this industry has problems environmentally and economically. So our aim of work was to use neutral membranes, ultrafiltration, modified ultrafiltration membranes, and compare it with the commercial membrane and discuss the recovery of the lactose. Why the lactose? The lactose mainly is one of our important products, so because it's used pharmaceutically as a binder or as a filler in food processing, in bakery industry as a natural source for sugar, in fermentation in bakery industry, and a bacterial identification. The preparation of the modified membrane, we used a modified membrane was fabricated in the flat sheet membrane in Natural Resource Center. It was mainly produced as a PVC, as a main polymer of concentration 16%, and NMP, we are using 1% polyethylene glycol. And for the anti-fouling process, we added zinc oxide and titanium dioxide of 0.1%, casted over non-moving polyester supports using Dr. Blade knife or with thickness 200 microns. Soaked in water as it's an unsolvent phase, and casted membrane was stored until used, and the membrane was cut as a spiral wound. The system setup. Okay, this is what the setup of our process. It was the feed tank, after that the UF to avoid the fouling of the RO membrane, followed by tank to save the product. Mainly it was an open loop, so we getting off of the waste, and the RO membrane for the pure purification of the water, the wastewater membrane. And this is the actual system, and it was purchased from the Egyptian Society of Membrane Technology. The membranes used was commercial ultrafiltration, modified ultrafiltration, and commercial RO. The characterization of the commercial was hollow fiber, and the modified was spiral wound. Okay, and this is the SEM of the membranes, the morphology of the surface area for the modified UF, and the hollow fiber UF and the commercial. And for the cross-sectional area, it was for this process. There was a dense layer due to the nano of titanium dioxide for the anti-fouling. So it was so dense referring to the RO. So it was the porosity was decreased as much as possible, and so improve the purification. For the results effective time, we mainly used the COD purification to determine the effect of the separation. For the lactose percent with the percent of the lactose, the separation for mainly the commercial and the modified were approximately the same. And this was logic for us because the lactose is of a smaller molecular size. So it was, for us, it's okay. But after changing the percentage with a real the protein and the real skim milk, the purification of the modified membrane was giving a better performance for around 70 to 80%, referring to the commercial one. And after we follow the membrane with the RO, it gives up the best purification as 100% of purification for the mainly the synthetic feed. And after changing the percentage of the lactose with the skim milk, it was a mixed dairy product. The efficiency also was around 60% more effective than the commercial one. And after that, we changed also the product, and it was giving us. But after we increased the percentage of increase the percentage of the dairy, the mixed dairy, the performance decreased to 40 to 50%. But still the RO gives the perfect separation. For the normalizing of the flux of the membrane, the effectiveness of the refined membrane is still giving a very effective fouling. Okay. For the conclusion of the fabrication of the flat sheet membrane, we recorded that the reduction of mixed dairy showed that a great development, and we can use this for the separation of the lactose with a low scale and the low cost, and we can use it as a multi-stage and preventing the use of the RO membrane. Okay, thank you. Sorry.
We have some questions. Very nice job. What I have the temperature on this.
It was I used the automated room fridge without increasing.
Increase the temperature, the efficiency could be enhanced.
What? Sorry?
Increase the temperature.
Increase the temperature?
The efficiency could be enhanced.
I think yes.
Yes. Any other questions?
Thank you.
What is the cutoff of you?
No.
What is the cutoff of you?
It was cut at the Faculty of Science in Egypt with 100% of weather science. And they tried for the nitrogen, liquid nitrogen, but it wasn't available at this moment.
The cutoff this means was the this is which in you 90% separation.
Sorry?
Cutoff membrane means that what is the separation? Get you what is the type of membrane get you separation more than 90%. ايه الاشياء اللي بتاعي اكثر من separation؟
أنهي membrane؟ طبعا for sure الار او هو اللي بيدي اعلى برسنت، بس انا باخد الار او بعد اليو اف. يعني انا عندي اليو اف الاول كبري تريتمنت قبل الار او، بعد كده بعديه على الار او. بس طبعا الار او عشان البروسيس اقل، فهو طبعا بيدي البريست بس هيحصل له بروبلم. الكوست هيبقى معايا مش لازم.
Cutoff in membrane this means what is the separation percent reach to 90%.
The cutoff is not studied.
Cutoff not studied. It's a part of it.
Thank you. What are the closing, please?
Okay, ladies and gentlemen, we are at the end of our presentation, our day. Also, and I hope that you all appreciate. Thank you very much.